Hi, so this is going to be a quick refresher of polynomial division. But before we get into that, let's take a quick look at polynomial multiplication. So what we're looking at is we want to know the product of these two polynomials, and what that means is we're looking for a rectangle that has this length and this width. And the sum of all of these little rectangles will equal the area of the big rectangle. So just multiply the length of this rectangle by the width of this rectangle, this little one, x squared times x squared, x to the fourth. And now we just need to add these up and find the area of the whole thing. Now, the nice thing about doing this is we have all of our x to the fourths right there, all of our x to the thirds right there, all of our x squareds right there. This should be an x squared. It's an easy way to check myself. X squared times 1 is 1x squared. All of the regular x's, x to the firsts, and all of the x to the zeros, and the no x's are right there. And when you add up all those, you're going to get the area of the entire rectangle. Division is just doing that backwards. Here we have the area, and here we have the width, and we want to know what is the length. So we're going to do this again. The problem is, I know that these two will add up to something, and these three will add up to something, these two will add up to something, and I know that that something in this next problem is going to be these things, but I don't know exactly what the pieces are that are going to add up to those numbers. So that's the challenge of doing the division. But we're going to start the same way. We're going to say x plus 4 here on the side. That's the length or the width of this entire rectangle. And here's going to be the area of the rectangle in these little rectangles here. I'm not quite sure how many I'll need right now. What I do know, though, is that all of the x to the fourths are going to go here. X to the thirds are going to go here. Because the leading coefficient's x to the fourth, that's going to be the third one, x squared, etc., etc., etc. And then no x here and no x there. And I know that there's a 1x to the fourth. So, again, we have the length times width of this individual rectangle. We can ask ourselves, what times x gives us x to the fourth, because length times width needs to equal area. This rectangle here, we know that the length is x to the third and the width is 4, so that's going to be 4x to the third. Between these two rectangles, we need to have a final sum of 2x to the third. That's how many we're looking for total. So what do we need to add or subtract from 4 to get to 2? And that's going to be a minus 2. And we're just going to repeat this process. We know the area, we know the width, we can find the length. We know the length, we know the width, we can find the area. And we know that these two need to add up to the x squared term up here, and there isn't one. So we can write it in, or we can just recognize that it's going to be a 0. Sorry, this should be 8, because negative 2 times 4 is 8. And repeat the process. What times x gives you 8x squared? 8x times 4 is 32x. These two need to add up to be negative 3. What times x gives you negative 35x? Length times width. And we need this to equal 10, so we need to add 150. And because we can't divide 150 by x without keeping it as a fraction, this is just going to be a remainder out of this entire divisor. So this is the quotient of this polynomial divided by x plus 4.